the desk of Ladyada from Adafruit.
Hello.
How's it going?
Okay, what are we doing first?
All right, so to kick it off, we have a bunch of big news. I don't know if folks know, but 4th of July is a holiday.
America.
That was the 4th of July. That was on Friday, paid holiday for our team and more. And then lots of folks off over the weekend, and then back to business. But a lot of people don't realize if you put out stockings on 4th of July Eve, Benjamin Franklin comes along and gives you presents. So open up your presents.
Okay.
America Day. He was not a president, but he's on the $100 bill. Very interesting.
Yeah.
An inventor of sorts. Okay, open up your presents.
Okay.
Let's go to the overhead.
Yeah.
Okay, get that thing out of the way. That's from the past.
Okay, first step is...
open that up. Yeah. Okay, that one on the right. Yep, that's an AI brain. Okay, so close that up. Yeah, we'll deal with that later. We have to get the memory stick reader. Okay, next up.
Nice.
Yeah, next up. Okay. This is
Sorry.
a pack of cards. Why don't you open it up? Oh.
It's lizards.
Did you already have this?
I didn't own this yet. No.
Okay, great. I want to make sure that Benjamin Franklin didn't get you something you already own. This is the episode where Tom Paris goes faster than Warp 10, kidnaps Janeway. They have kids and they leave them behind. These are the kids.
We don't even know if they're like self-sufficient,
Yeah. Okay.
Great.
And then the last thing.
Threshold.
The last thing is you hold it up. Hold it up. Hold it up. No, not those.
Oh.
Ta-da!
I'm having lizards.
Yeah. Tom Paris, I'm gonna get you. Look what you did to my Janeway. Okay, so we're gonna have another kid.
Yeah, I went faster than Eagle Cat 10.
Yeah, so we'll have more information later. This is all we're sharing. Hopefully, it all works out. We had a kid. We love her. I think she'll make a great big sister. We'll tell everyone we're gonna take a little time off towards the end of the year and more. But that's our big 4th of July news. But for some of you, you're saying,
we're having lizards.
Where's my packages? Don't forget, we're not shipping again until Monday because Friday was a holiday. And then for folks who are really interested, you can watch me live blog on adafruit.com/Slackforce, or you can just go to our Learn system and look at the guide on how to disable your Slack settings, because our Slack rep, this is a 6-fingered Slack logo. Our Slack rep, and I'm sorry, Jude, that I have to include you in this, but that's just the way it is. I left out the Hey Jude jokes and stuff and Beatles things. I love Beatles. I love the song. Even the rep, he's a nice guy. But he jumped into this. He said AI is all around us and it was really hard to get a straight answer. So anyways, we're making sure that our team is not going to have all of their Slack messages eavesdropped and turned into tools. Thank you, Ladyada, for having that as a cool part of our company. So folks, if you're you're opted in already, you have to opt out by the 17th. Check out that. This is our favorite tariff blogger, tweeter, Xer, whatever. This is the CEO of Shareport. What is it? Flexport, yeah. And he made this like AI thing. So we'll know more this week about tariffs. It's a weekend, so everyone's doing other stuff. And that's pretty much it for this week. Please know, only in America could we have an Adafruit, a Ladyada, kids, and all the things that make us so happy and over the moon with everything that's happening with our lives. And we don't share a lot, but this is the little piece. And thanks a little more for letting me share this with our community more. I know everyone's going to make sure we have a great holiday, and they're going to be super supportive, and everyone's going to be nice online, and you're going to put out even more electronics, and we're going to have 2 more engineers into the world before we're too much older. Okay. Let's kick it off. What are you going to do this week on Desk of Ladyada?
Okay, so let's go to the overhead. Again, no lizards this time. So I got maybe I'll turn this around. I got my prototypes for the BQ25 798. So, I've been playing around with all the LiPo chargers from TI. They do just a really good job with LiPo chargers. And I really like this one. I saw this because someone referenced it in some other project, and I was like, oh, what's this part? So this is a really cool charger because it's a buck boost charger. So you can have any voltage from 4 to 24 volts in. And it can charge any size lithium ion or lithium polymer battery from 1 to 4 in cells in series. So like, I think, obviously 4.2 volts, 8.4 volts is 2, and then 12.6, and then 16.8. I don't remember, whatever, do the math. So you can do very big battery packs. They can charge up to 5 amps because it's buck boost. So there's no like thermal issues. As long as you have the current to charge your batteries, higher volt, a 20 volt, 5 amp power supply is fairly common. The only thing it doesn't do is USB PD. If this takes off and it's really popular, I'll do a USB PD version because that'd be really cool. It's the only thing it doesn't do. So, but hopefully they'll make a version coming up that does do that. Wouldn't that be so cool if it like automatically did the USB PD negotiation? Oh my God,
yes.
Awesome. So, so one thing that is nice about this chip is it does have autonomous charging. The bad part is that to turn on the MPPT capability, max power point tracking for solar, you do have to connect over I2C. It's like 1 bit in 1 register, but it's not on by default. And there's no like EEPROM setting. So, but regardless, it does have some cool things like, obviously voltage, current monitoring, and temperature monitoring, and it tells you like your solar panel voltages, and it, it does quite a lot of stuff. So, when I plug it in, I verify just the voltage, the LED turns on. It flickers because it's like there's no battery connected. But, I did do like, a quick, just like, sanity check by measuring the LiPo voltage here. And it's floating around like 4.2 volts. So cool. And then I flipped all the little switches. I did mislabel them. This is 3S, but it's actually 1. I got the resistors swapped around. So it does, at least that switch does select between 1 to 4S. And I2C does connect and the LED does blink. So far, so good on just like hardware tests. The next thing is the software. So you go to the computer. I think we're done with the overhead for today. Pardon me. So the one thing about let me grab the data sheet from over here. The one thing about this chip is like, it's so cool. It also has like 1 trillion registers. It's just like, and like, it has like 1 quadrillion register flags because each register can have all these bits for status and reading and writing, and it's a flag. And, one thing I always say is like the hardware design, it's like, we saw this like guy tweeting, or this person tweeting over the week, and they're like, I'm going to automate the Adafruit factory. And I'm like, the hardware ain't the hard part. I mean, it's hard. It's hard in its own way. And like, if it doesn't come out right, but there's like a fair chance that like this design, Web A, is correct. That's not, and that, it took me a couple hours. That's not what actually takes a really, really long time. It's actually the firmware that takes a really, really long time. It takes much longer than it used to. Sorry, it takes less time than it used to because I used to have to do this all by hand, which means what I would actually do is like, to save my wrists from explosion and my brain from cooking, I would just pick like, what are the most important registers, turning on MPPT, reading the voltages and currents just to see if it's working. I wouldn't like mess with all the weird ass little flags. Like, there's like dozens of like tweaky ass flags that you can set. And I'd be like, if people demand it, I'll add it. But for the most part, I'm just going to go with the basics. But now I'm actually using Claude Code to write drivers. And what's really nice, and first off, it's cool because I now commit through Claude Code. So I actually get the little like ding dong, like it was committed with Claude. So people don't have to add, because I can't attach a log anymore from Claude Code because it crashes and I'll lose the history. It would be really cool if there was like an audit history, but they haven't added that capability yet.
Okay, so you want an audit history in there?
Well, I mean, I think like if somebody's writing Claude Code, it would be cool. Like somebody's using my API key. I'm like, what was the prompt and response?
Okay, so I'm going to just send a note to myself. So like 10 minutes and 20 seconds in, I'll tag Anthropic and I'll say, hey, Ladyada Lamore is pregnant and this would really help her a lot. Why won't you help the children now?
Yeah.
So yeah.
Don't you care about the unborn?
Yeah. No pressure, guys. So you want it to do what?
So I use Claude Code, which is an API key interface. And I love it because it can do commits and it can do like GitHub stuff and it can like go to the web. It's like really nice because it's a command line interface. But there's no way for me to attach or reference the history of all the prompts. Like I used to do that with ChatGPT. because you could click and say like, oh, I want the history, and I would be a web page, and people could see what I typed, and it was a really nice way to show like, here's how this code was written, not just the output, but what are the prompts that I.
We're not freeloaders. We pay money. What is the most? Please answer. What is the most we paid in a week to Anthropic? You think?
Well, we definitely pay like $500 a month just for all the accounts, and then we easily pay an extra like $200 a week.
Okay.
Some weeks we pay for the
Worth
credits.
it?
It's absolutely worth it.
Is it a deal?
I think it's fair.
Okay. If it was twice as much, not a deal.
I would demand more if it was twice as much.
If it was free, what would you do? Anything different?
No, nothing different. It's not that expensive, so I mean, yeah, I mean, whatever.
Maybe because it's not free, it keeps the riffraff out, so we can get some work
Well,
done.
there's a limit. You know, if you use the free version, you have a limit.
Yeah.
Anyways, let me keep going.
Yep,
That
was it. I just because people are going to ask, I needed to do this. Okay, great.
Yeah. Okay, so it I like it does commits now, and it writes the test. And what's neat is like, just I'm still there. Like I have to approve everything, but it's written like 800 lines of code, and it does the doxygen, and you see it's very boring and repetitive code. There's no thinking. It's like the register, the bits, read them, return it, and there's like the float. This is like the current limit for the on-the-go setting,
Right.
which again.
One thing. So jerk faces, we have to get sonograms and have to go to the doctor a bunch of times. We wouldn't have all this time because you'd be doing other stuff. So this is really helpful for us. This is good.
Well, I don't care. Like, I don't care.
No, look, I have to send a link when someone says da 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 because I'm going to send a picture like this, and you're going to be like, look, I'm making lots of things over here, code and kids. What do you want me to do? I'm printing as fast as I can.
know. It's like anyone out there who's gone through like a first trimester. It's like you don't want to get out of bed. So it's like I can code from bed, and
you can use voice prompts.
I tell it what to do, and I just don't have to do the repetitive doxygen.
Anthropic is doing great marketing. I can't beat that, but this is like a very nice commercial of like, here's a professional woman, CEO, founder doing all this, and this is how we're getting work done. Okay, sorry, Mark.
Okay, so that's working. So the library, so it's public. It's partial, and my goal is actually with this is because historically, like I don't like to finish I kind of don't finish the firmware. I'm going to really try to get through, like every night I do an hour or two after we put the kid to bed, and I can just like sit down and chill. And I'm just like, okay, I just check it against the data sheet and make sure it's doing the right thing. And then I approve. It's like, approving a PR. And then I have it write the hardware test. And I use Arduino CLI to actually test against the hardware. Like I have it upload the code to the board and then make sure that the register reads are correct, especially when there's a default value. I'm like, is the default value what the default value of the data sheet says? Because that's like a really good, very basic test. Because like I don't know if I'm going to be able to hardware test every single register read in, right? I'm probably going to just test the ones that are like, again, the most useful and interesting. So that's coming along. And then after I do that, then I'll start actually setting up like more intense hardware tests because I'll be able to use I don't want to like bounce between hardware and firmware. I want to just like get all the firmware done and then I'll do it. So it's, it's nice. So the next thing we did is a couple of breakouts. Pardon me. So I did a couple of sensors actually. Oh, so one is let's go back to batteries and power. I was thinking like this board is kind of chunky, and I wanted maybe I did like the idea of like a buck converter because we don't have a LiPo buck converter, and when you have a linear battery charger, you can't really get past an amp because just the thermal management of pushing an amp with a 0.8 volt or 1 volt drop, it's just like gnarly. And so I made, I kind of was looking at other chargers from TI, and I like this one. I made this one is nice and compact. It's much smaller, has USB or DC in. This one just uses a simple, Schottky diode. And then I have a little selector here. I like these little dip switches. We covered them on the Great Search, and they're just like tiny little. Maybe we'll go to the overhead again real fast and just show them off because they're just so cute. Because it's hard to see on the outline, but you can. They don't like slide around. Like once you set it, it's like nice and permanent. But it's easy to switch without needing any extra tools. Like you just use a pen. All right, so back to the computer. Thank you. Oops, let me just remove the extra view. So this is a little flicky switch for 0.5 to 2 amps. So you can select that on the fly, which I really like. There's system out, there's load out, and there's LiPo out. I do have to figure out, like, if you give it 18 volts here, does the load out give you 18 volts? This does have also I2C. What's nice is that the I2C is not required. It does do fully autonomous running. The I2, unlike the MPPT charger, which you need I2C to enable MPPT, kind of a bummer. But this one does fully autonomous charging. And then if you connect I2C, you can do stuff like monitor the voltages and current and be like, hey, tell me about, like, what is my battery state, how long until it'll be charged, et cetera, but it's not essential. So I like autonomous chargers, but I also kind of dig that there's this optional I2C for, like, I want to, monitor it if desired. And then, there's just a lot of breakouts down here, but it's meant for just like, I have a single cell battery, 3.7, 4.2 volts. I want to charge it at 2 amps. Again, we don't have a 2 amp charger. And it's like, it is annoying to charge our bigger battery. Like, we have a 10 amp hour battery pack and you want to charge it fast. While this is not designed for solar, it actually could probably do non-max power pointy, just because it's got, it has the voltage and current limit setting that you can do, and you can kind of like tweak it to kind of work well with solar. But the other one is like solar specific. And then, pardon me, back in, breakouts and sensors. We used to stock the HMC 5883, and I actually noticed a lot. I was actually looking at a open source drone because we were like talking about open source robotics, me and Mr. Ladyada, and I noticed that a lot of drones, like low cost, like DIY style drones, like the little ones, not like DJI drones, they tend to use the QMC 5883, which is like, it's not like a knockoff. It's just like a pin compatible, code compatible ish version of the HMC. And because the HMC got discontinued, I was like, oh, maybe I'll make a quick breakout for this board. Again, it's like I got to recycle most of the board, but the old version I had wasn't STEMMA QT. This one's STEMMA QT. So it'll make it, if people want to do quick, like DIY sensing, that'll be good. And then last up is I did a breakout. We covered this chip on INMPI. I'd also do it for the Great Search. This is an IR temperature sensor. Specifically, I want to get this because, first off, people have been asking me for one for a while, and it's kind of like didn't realize that such a thing existed, like a surface mount IR temperature sensor. But I have a joke with the Adafruit.io team that like 80% of our most cherished users are growing weed and using Adafruit.io to monitor their plants. And one of the things that people who grow plants really need is to know the vapor pressure differential or something. I don't remember, the VPD is what they call it. And to do that, you have to know the temperature of the leaf canopy. And it's really hard to attach a temperature sensor to a leaf because like they're floating around. You don't want to cover them. So people use IR sensors. And so they're like, oh, can we get like a STEMMA QT IR sensor that's like you could put on a long cable and point it at these leaves and know the leaf canopy temperature. And I was like, oh, we don't have an IR temperature sensor. And then I was like, you know what? I'm going to go to DigiKey and find if there are any new, since I last looked a few years ago, IR temperature sensors that are surface mount. So that's the Great Search.
Okay, let's kick it.
Where in the world is that part I need? The Great Search with DigiKey.
The Great Search brought to you by DigiKey and Adafruit every single week. Ladyada helps you find the things you're looking for on digikey.com. Ladyada, what you looking for this week?
Temperature sensors. So one of the early sensors / boards that we stocked was this MLX 9614. And this is a cool sensor. It's a through-hole, breadboard friendly infrared temperature sensor. And what it does is it measures the infrared light bounced off of an object, and it uses that to calculate the temperature, and it's calibrated. So it can give you like a really good approximation of the temperature within a couple degrees. The downside is it's through hole. I mean, it's a pro and a con, right? The pro is like, oh, like it's great for beginners. They just plug it into a breadboard. They wire up SDA and SCL to their Arduino, and like you're good to go. You can even like connect little wires on. As long as you have pull-up resistors, either externally or on your board, you're good to go. But the problem is that, and I think we even ship it with 2 resistors. The problem is that I wanted something that was very plug and play. Like if we have STEMMA QT, we have a lot of sensors and boards that I can quickly, like this actually. This is a thermal sensor that has STEMMA QT on it. It's just plug and play. It's so easy to connect, and you don't have to worry about getting pins wrong, and the voltages and the level shifting is handled for you. So this is another sensor. This one's much more expensive. This is $75 compared to like $15. This one is a 24 by 32 camera, so it actually kind of gives you a full, like a matrix grid, so you can actually look at like hands and devices and like environments, and you can pinpoint where the temperatures are, which is like super neat. And we have a couple projects. Like this one is kind of a cool demo. You can do overlays and stuff as well. We'll do a couple projects of that coming up. But what we wanted was something inexpensive. I mean, this is a great sensor, but it is $75, single point, just one measurement, and without having this through hole complexity. I wanted something surface mount. So let's go to DigiKey. And we can look for, so I want to mention one more thing. We used to carry a sensor that did this. It was called the TMP 006 and 007. In fact, this was very early, product number 1295, very early in our existence. And then they discontinued the 12006 and came out the 12007, Temp 007. We had this one for a very long time. Great little sensor, worked fairly well. You just have to kind of like, know what you're getting out of it. But it was annoying PGA, and then they discontinued it. Why? I don't know. It's kind of rare for TI to discontinue stuff, but they did. So what I want to do is basically find an alternative to the TMP 007. Another thing that was nice about this, it was fairly inexpensive, which could be also why they stopped making it. The yield didn't allow for the price. So obsolete, but let's find another temperature sensor. So let's go to temperature, analog, and digital output. And there's a lot available. And most of these are local temperature sensors, right? They'll tell you the temperature at the chip itself, which is quite handy. That's not what we want. But first, let's start with just active. So you just filter out what's not available and what's available. So let's select those. Because I only want something I can get. And then, so for types, there is, if they don't mention it, it's local. It means it's at the chip itself. So what we want is the infrared. When it says local but not infrared, I've noticed it's usually a thermocouple or a thermistor. So it's like you can connect an external item to measure temperature, but it's not, again, that item still has to touch the sensor, which we don't want. We want IR, which is fully, like you just point it at the thing, and as long as it's within like 6 inches, you'll get the temperature reading. So I got infrared, digital infrared, and analog infrared. I don't know if I'd get the analog, and use it, but we'll see. If it's like very inexpensive, I'll just put ADC on there and get the digital output up. So that really cuts down the number of items. Let's go see what we got. So as expected, we've got those MLXs. This is the chip that I just showed you guys. And they do have like a lot of varieties. They, this really worked out for them. They have like ones that are very narrow, ones that are wideband, like Amphenol makes some of these. Some of these, the analog ones, I will warn you, a lot of these are inexpensive. So this one is like, only a couple dollars. The reason is that you have to convert, it gives you a resistance, and then you have to convert it. And one of the things that is an issue is that the local temperature will affect the resistance as well. And so you have to do a lot of calibration to figure out like what is the local temperature, and then adjust that to figure out what the remote temperature is, and then like do this math and calculation. So these, you'll see these thermopile IR analog sensors in low-cost products where it's like, we're making 1 million of these remote forehead temperature sensors. And so it's worth it to save $6 per sensor, $5 per sensor. And then we do a calibration procedure in the factory. I'm not going to do that. I don't expect my customers to do that. So we're not going to go with those. Instead, let's get rid of the analog and just do digital infrared. So we get rid of just those sensors. And then another thing is some of these are through hole and some of these are surface mount. We want only the surface mount ones because that was the whole deal, is I want something that was pick and placeable. Although we could, sort by price. Oh, one thing that's kind of neat, that's new, is you can drag the, so it's like if you really care about sensing temperature the most, and you're like, oh no, it's like this is so long, you can drag over the thing that's most important for you. So let's do price by quantity, about 250 pieces, and just see, if a through hole one popped at the top. This one is, it's like $1.50 less. Just gonna look at this real fast. This is calibrated outputs. That's kind of nice. And it's I²C. So I'm probably not going to use this one because, again, it is through hole, and that does add a lot of effort for functionality. Also, I want to make sure, what is the voltage? Do you need 5 volts or can it run on 3 volts? Okay, going from 2 to 3 volts. This is actually cool. This is actually a really nice chip. I think this is kind of Amphenol's response to the MLX series. It's a much less expensive chip, but it's not significantly less than these enough. I think like the $1.50 isn't quite enough to justify that I'd have to hand solder and then clip the leads, because that adds quite a bit of labor cost. Also, I'm probably going to end up buying more than 250. So let's, given that, let's get rid of the through hole. Where were we? Okay, chassis, panel mount, surface mount. So just select surface mount. And a couple options. We've got this TPIS series from Excelsius. This AMG from Panasonic, we actually use this. It's an 8x8 sensor. So it's more expensive. It's on the $20 range because it's got, again, 64-point grid of sensors. Very cool. We already have a breakout. But the one that I liked, and again, this is, also ended up on IMPI because it's was a featured product, is the MLX 9320. And what's nice about it is it's surface mount and pretty small, and it can run on 3.3 volts, which is great. And they have a cool medical calibrated version, which is a little bit more expensive. But if you look at the calibration, and it's pre-calibrated, which is, again, also like really nice because that's the, if you have the setup, it's easy and inexpensive. But if you don't, it's a total pain to do. If we go to the calibration, so the standard calibration has range from -20 to 200 object temperature centigrade, which is a good nice range. And it can do, it gets you, as you get to hot or very cold, it changes. But as long as you're around room temperature, it's about 1 to 3 degrees off accuracy. But the medical, what's really nice is that if you're measuring mammals or other living things or plants, it gets very, very precise, much better than 1 degree C at the ambient temperature about room temperature, and ambient temperature also, and device temperature also about room temperature. So like basically things that are like meat, vegetable, not boiling hot, not freezing cold, you're gonna get really good precision. So I might make 2 versions. One that's a less expensive, that's like, okay, you don't need more than plus or minus 1 degree C, and one that's the medical temperature. So this is my choice for the Great Search. So I'm gonna make that breakout and see how it goes.
And that is the Great Search.
Where in the world is that part I need? The Great Search with DigiKey.
America. America. That's the song
Okay,
that
we're
our
out.
kid knows. Yeah.
Yeah.
So let's go and enjoy this joyous weekend, Our Ladyada. And I am hoping and wishing and using every fiber of my being to hopefully build a better world. Maybe not even better, just more suited for engineering and learning and sharing for this new life that maybe we're going to bring in and be a little sidekick for Kid One.
Okay. All right. Thanks, everybody. Thanks for watching.
Bye-bye.